I'll be explaining about matter, which is anything that exists. The floor you are sitting on, that's matter. The whiteboard behind here is matter. And all your skin and everything in your body is matter. It's hard to keep this thing up. Here, I'll hold it.
Thank you, Teyo. Bring a problem solver.
If matter is big enough, you can see it, but if it's too small, it's hard to see. And as you can see, this blade of glass is big enough that you can see it, and the dewdrop you can see it because you see it a lot. We live in Seattle, it rains. But as you get smaller and smaller and smaller, it shows in this picture, you go from the water molecules to the hydrogen atom and the forth. It's hard to see. Yes, well, it's hard to see it. So now I will be explaining about these molecules, which are these atoms, which you probably don't know. No, we didn't talk about atoms much. We didn't, yeah. So these hydrogen molecules, these hydrogen atoms, they would be a proton and an electron with no neutron, because they're the simplest elements around. They're really small and they don't react with much. Yeah, I was gonna do that. So protons and electrons are some of the things that compose an atom. So a proton is if you have an oxygen atom, you have neutrons in it, because if too many protons are in the nucleus, some of the protons will fly away from each other, because like magnets, the same side repel each other. So it's sort of the same idea.
So like if you're imagining the solar system and you have the sun in the middle, that would be the nucleus. Like everything orbiting around it, instead of just orbiting around in a circle, these would be the electrons, and they'd be going like all over, and that's called a shell.
Yeah, these imaginary circles around the nucleus.
And the nucleus would be like the sun, except it's made of subatomic particles, which are particles that are smaller, which are protons. So we have a proton here and a neutron here. We have to have neutrons to balance out protons.
And also, electrons, they're really fast because they have almost no mass. So so they're point zero 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 zero. We get the point 9 pounds, which is really light. That's which explains why they spin around. So yeah, and as you see down here, the reason why the neutrons and the protons can stick together, it's not just random. So they researched and they found that protons and neutrons are made up of quarks, which quarks form a lot of other subatomic particles.
It's really complicated. But there are different types of quarks.
And as you can see here, there's 2 up quarks and 1 down quark in the proton. Because up quarks are up, and down quarks down. And then the neutron is the opposite. There's only one up quark in the proton. Yeah, you can want that.
Okay. So antimatter is like the opposite of matter. So I guess I'm not completely sure about this. Well, it's like everything here turns opposite, so it would be like an inverted atom, I guess. You can make it.
Yeah, so here's an example of here. There's the thunder, during the thunderstorm. So the thunder creates gamma rays, which are the red squiggly lines. And they hit hydrogen molecules, which when
it doesn't have to be hydrogen molecule.
Yeah, it can be other molecules, because I just put hydrogen because
I thought it
hydrogen
was atoms. I thought they hit atoms. Well,
Yeah, they hit.
To hit atoms, they have to hit a molecule. But the gamma rays, it's very rare, but they rarely hit against an atom, which will make it break apart into two things: an electron and a positron. Electron we already talked about, but a positron is
It has the same mass, but it has the opposite charge.
and so like how these guys are made of up quarks, and down quarks, they're also antiquarks, which are the quarks of antimatter. So there can be up antiquarks and down antiquarks, which would make the opposite of a neutron. But I don't think it would be
An
called
anti-neutron and an anti.
Oh, really?
Yeah.
That's what they're called?
Yes.
Oh, wow. Okay. I didn't know that. But that's how antimatter is created. It's
That's
just like matter.
thunderstorms is just one way.
And there are many ways.
Sure, yes.
Anything else on this?
I have a question. You keep using this word mass.
Oh.
Can you explain that term a little bit? What mass?
It's basically the same. It's to calculate it. It's weight, but weight it's caused by gravity. But mass
It's
is
not
not
weight. It's weight times something, isn't it?
No.
Okay. But mass is the force it takes to move stuff, isn't it?
Yes.
Okay, mass is the force it takes to move stuff. And since electrons have so little mass, it only takes a little bit to move them, and that's why they move so fast around stuff.
So it's a lot lightweight, but without gravity being involved.
Yes.
Yeah.
Right. So, like if you went on the moon, you wouldn't have any less of your body, right? You wouldn't be losing any matter, but you would be lighter because there's less gravity. You're able to jump really big.
You
You
still
have the same mass. So it's kind of like how much matter you have.
Yes.
Yeah.
Ish. Have you thought about it that way? All right. Just clear that.
And so there are many subatomic particles, but four main ones are composite particles, which can be splits. They're smaller than atoms, but they can be split.
Aren't they?
And then elementary particles, they cannot be split, which an example is a quark. An example of a composite is a neutron and a proton, because they can be split into quarks. And then the next one would be
It could also say the thing you did was not okay. The thing you did, that's not a subject. So today what I want you to remember is that not all subjects
there's four types.
Wait, aren't there? Well, there are more than that, because if you're counting different times, because there are different, you can count it in different ways. So technically, there are 11 types of particles altogether, but of subatomic particles there are only 6, right?
That's the only time I don't have to use the subject. Because the subject is hidden.
Okay, now to this.
It's the word you. So every time I give you a command, I don't have to say the word you. You. Get it?
So this is explaining matter.
I just dropped off the you.
Our world is made of matter, but what is it? Matter is anything that takes up space, such as that bit of fire up there. Particles are microscopic specks of fire specks of matter that help create everything in our universe. But first, you have to know about
Or
atoms.
there are some new rules.
Atoms are particles that help make up the Earth. These guys are made up of 3 different types of subatomic particles named electrons, protons, and
Is our
neutrons.
subject.
Neutrons, the blue circle in this picture, stick together with protons, the black circles in this picture, which creates the nucleus of the atom. This is possible because they're held together by strong nuclear force.
This word it is kind of like a pronoun and it stands in the place of others.
So the quarks that make up
11 a.m.
the neutrons and the protons,
Instead of us
they're
saying the clouds or the sky,
gluons
weather is raining.
bind them together.
We explain gluons later, don't we?
The word it is often
No.
Yeah, we explain gluons later in this PowerPoint.
No, we don't.
Yes, we do.
Should we click forward and check just in case?
Yeah, just click forward.
I'm not going to do that because it'll upset everything. If you're not sure what's coming up next, just forget about it for now.
Okay. Anyway,
Slide.
they're stuck together by a certain type of subatomic particle.
called gluons, which contain the strong nuclear force, which helps them bind together.
Okay, got it. Okay. Electrons are tiny circles floating around, are very light, being non millionths, a 9 falling 27 zeros behind the decimal point, 1 pound. They spin around the nucleus at billions of miles per hour. Protons are 1,836 times as heavy or massive as electrons.
We call that the verb phrase, but today I just want you to find the one verb. Her flight across the Atlantic in 1932.
You may be wondering why neutrons have to be in the nucleus. Let us explain. Suppose you threw 2 balls in the air, the balls being protons. Suddenly, the balls fly away from each other. If only protons were in the nucleus, there would be no nucleus. The protons fly away from each other when they are together.
Also,
Magnets.
there's one neutron per 2 protons in the
Her.
Right, which means 0.5 per neutron. But you wouldn't have half a neutron in one that only had 1 proton. That would be weird.
Yes.
There are many types of particles, so we can only tell you about a few. Let's start with elementary particles, which means that they can't be divided into smaller particles. Basically the same as subatomic. Smaller particle about photons? What? Okay, photons, for example, have no charge and no mass. There's so many elementary particles, so we're just going to tell you what? How did this got all mixed up?
Probably could have taken another recess to review this. Looks like, yeah.
So we're just going to.
Is your
What?
verb.
Okay.
She married J.P. Putman.
Photons have no mass, no charge, no mass. The force and no mass. The force it takes to move an object, and it still emits light.
Married? Are they
So
both?
photon is what emits light. This part of the sentence down here
It got
is supposed to go
up.
after.
Yeah, no, it was supposed to go up here.
I think it was supposed to come after photon.
Well, part of it, because there are so many elementary particles, we're just going to tell you what about a few was that there's so many.
Yeah.
Married is
Look
the
like-
verb.
Antimatter is basically the exact opposite of matter. I know it sounds confusing, and it is. You don't have to understand all of this right now. Anyway, but it's so cool to imagine a world of antimatter.
Breaking records is the
We hope you learned a lot today, and that you want to learn more. So bye for now, but keep learning about what our world's made of. Rectangles!
What?
Yeah, that's
Um,
it. Yeah,
not in this rectangles. Remember, was is oftentimes.
So, a little bit of feedback. Pretty sure you can tell when I'm